Hi, welcome back. It's Common Core Algebra 2 here. Today we're going to do 9.4, which is the discriminant of a quadratic. Basically, we talked about this before in class, and we've talked about how that discriminant, which is that b squared minus 4ac, can truly make you understand what the roots are going to look like. So we call that the nature of the roots. Are the roots going to be rational? Are they going to be irrational? Are they going to be complex? Are they going to be one root where the parabola is tangent to the x-axis? Or are they going to be two roots? Or are there going to be no roots? So today we're going to talk about how we can use the discriminant to come up with the nature of the roots. So basically we broke this into 4 different cases. So the first case, case 1, all right, says that the discriminant is a perfect square. So here's an example of a quadratic where the discriminant turns out to be a perfect square. So let's determine what that is. So reminding ourselves that b is 3, so let's, because we need a is 1, b is 3, and c is negative 10. It's going to be b squared, which is 9, minus 4 times a, which is 1, times c, which is negative 10. So you get 9 plus 40, which is 49. So there's our perfect square. All right, so remember what that means. That means when we do our quadratic formula says it's the opposite of b, which is 3, so x is equal to opposite of b, which is, negative 3, plus or minus the discriminant, which we got the square root of 49, all over 2a, which is divided by 2. So our roots are going to be negative 3 minus 7 over 2, and negative 3 plus 7 over 2, which of course is equal to negative 5 and positive 2. So in this case, when it says number and nature, so here's our discriminant, here are our roots. So the number of roots are 2 because we have 2 different answers. So here we're going to have 2 unequal, and in this case, rational roots. And you can understand that because if we have that perfect square, we're going to get those nice numbers, all right, those integers, or they could turn out to be fractions, which is basically the definition of rational. Okay? So that is our first case. The second case, remember, if I'm going too fast, you just pause the video before I continue. So the second case, the discriminant is not a perfect square. So case 2, the discriminant is not a perfect square, and this is the example we're going to use. So the first thing we're going to do is determine what the discriminant is. So again, it's b squared, which is 36. Remember, if b is negative, when you square it, it still becomes positive. So when you do b squared, whether it's a negative 6 or a positive 6, it's still going to be 36 when you square it. Minus 4 times a, which is 1, times positive 7, which is c. Okay, so what does that equal? It equals 36 minus 28, which is equal to 8. So in this case, it's still a nice number, it's 8, but it's not a perfect square. Because when we take a look one more time at what our roots look like, going back to our quadratic equation, x is equal to the opposite of b, which is positive 6, plus and minus the square root of the discriminant, which is 8, divided by 2 times a, which is simply 2. All right, so our answers are going to be, now remember, I'm going to just remind you that radical 8, rad 8, is going to simplify into the perfect square and what's ever left over. So that's going to be 4 and 2 because it'll always tell you that it wants it in simplest radical form. So that means we're going to simplify rad 8 to 2 rad 2. So when we write this down, we're going to have x is equal to 6 minus 2 rad 2 over 2, and of course then we can simplify this to 3 minus rad 2, and x is also going to equal 6 plus 2 rad 2 over 2, which reduces to 3 plus radical 2. So you can see here that this time, even though that wasn't that much harder, the nature of our roots, we still have 2 of them. So here we have 2, and they're still unequal. 2 unequal, but this time we're going to have irrational roots. Remember, that's whenever we have anything left with underneath a radical. So that was our case 2. Case 3, the discriminant is equal to 0. So here the discriminant is equal to 0, and they're going to use this example here. So b squared is 100 minus 4 times a times c, which is 100 minus 100, which of course is 0. So what effect is that going to have on our roots? We're going to have x equals, I should change my color, sorry about that. So we have x equals the opposite of b, which is positive 10, plus or minus the square root of our discriminant, which is 0, divided by 2 times 1, which is 2. So we are basically going to get x is equal to 10 minus 0 over 2, right? And 10 plus 0 over 2, which is simply 10 over 2, which is equal to 5. So this is the only case that we're going to get one root. So here we're going to have one rational root. So 1, and it's rational, 1 rational root. All right? Now, what you don't realize here is we're saying one rational root. I mean, basically what we also have here is we have 2 equal roots. That's really what's happening here. And we're going to discuss that a little bit later on, what that looks like, because this is called a double root. Okay, so now we're on to our last case. And our last case is when our discriminant is less than 0. So hopefully, after just finishing up with the rest of Unit 9, you're going to have an idea of what this is going to look like. All right, so this is the example we use. I'm just going to add a little bit of room here. And we have b squared minus 4ac, which is 64 minus 4 times 1 times 20. All right, please don't think that a is always 1. We happen to be using examples where the leading coefficient is 1, so we're not putting in that third number for a. We're just leaving it blank because 4 times 1, of course, is 4. So this becomes 64 minus 80, which is a negative 16. So what do our roots look like? Our roots look like x equals the opposite of b, which is positive 8, plus and minus the square root of our discriminant, which is minus 16, all over 2 times 1. So what do our answers look like? X equals 8 plus and minus 4i divided by 2. So x is equal to, now we're going to cancel these both out by 2, so we're going to have 4 minus 2i, and we're going to have 4 plus 2i as our answers. So, how many roots do we have? Well, hopefully you're realizing we have 2 unequal, and these are complex roots. Did you say imaginary roots? The answer is, of course you can. We like the word imaginary better because it kind of gives you an idea that there aren't actually going to be roots. Because if we think about, again, what those roots are, it's where they cross the x-axis. So we're going to take a look at what that looks like on a graph when we get to one of the later examples. All right, so write down what you need to. Rewind if you need to spend a little bit more time thinking about these. But I think sometime in exercise 2, it might become a little clearer to you. And again, I remind you that practice makes perfect, or at least pretty close to perfect. All right, so if you think you're only going to do 1 or 2 of these and really understand it, you're not correct. Okay, it really takes some time and dedication to understand some of these concepts. Exercise 2. So we're basically going to look at what the nature of the roots are just by looking at the discriminant. Because if it asks you what type of root are you going to have, sometimes you can find that out in your calculator, but if they ask you to show it, then you have to use the discriminant. So let's take a look at what this is going to look like. I'm going to remind you the discriminant is b squared minus 4ac. We don't worry about the radical. We just worry about the actual content underneath the radical. So b squared is 49 minus 4, here we go, we have an a this time, times a times c. So here we get 49 plus, because the double negative is plus, 16 times 2 is 32. And when you add them together, you get 81. So because of our discriminant, we know this is a perfect square. Hopefully you know that. Red flag should be flying. This is Teetsa's favorite numbers, those perfect squares. So 81 is a perfect square. So we know that this is going to yield 2 unequal, rational roots. Because remember, when we look for the roots of this, that square root of 81 is going to turn out to be a very nice number 9. So we're looking at B now. And you know something? I really feel like if you have an idea of what we're doing, or you want to go through and at least find the discriminants on your own, and then listen to how we find the nature of the roots, I think you should do that, because I think it's really important to be able to challenge yourself. So pause the video now, you find the discriminants of the remaining ones, and if you don't want to go through and look for that 2 unequal rational, 2 equal rational, whatever it is, then listen to what I have to say. So here we go. B is b squared, which is 64, minus 4 times a, which is 1, times c, which is 25. So this becomes 64 minus 100. And without even figuring out that it's negative 36, I know I'm going to have imaginary roots. So 2 unequal imaginary roots. Okay, and I'm sorry, number C, I think it's the last one. B squared minus 4 times A times C, this time C is 1, and this becomes 16 minus 16, which is 0. So when it was 0, if you remember, that's when we got that double root. We only got one rational root out of this one. Okay, the board is writing spooky again. If you haven't done it yet, pause the video and try to find the discriminant of the next 3. B squared minus 4 times A times C, which is 36, minus 60, which is a negative 24. Negative means two unequal imaginary. E, b squared minus 4 times a times c, which is 16, minus 4 times 4 is 16, and 16 times 7 is 112. So it's going to be a positive, because I have a negative and a negative, positive 112, which turns out to be 128, which is a very nice number, but it's not one of my favorites. It's not a perfect square. Remember, let's see, 121 is a perfect square. That's 11 squared. 144 is a perfect square. That's 12 squared. So here I'm going to have two unequal, irrational, because we're going to be left with a radical, roots. And our final one, b squared minus 4 times a times c, which is, I was going to say 7, 49, minus 12 times 2 is 24, and 49 minus 24, is 25. That's my favorite number, one of them anyway. All right, so 25 is a perfect square. So here we're going to have two unequal rational roots. So I'm hoping I was able to add to your clarity with that example. All right. Okay, let's move on to exercise 3. When you're ready, of course. So now this is what I was talking about. I don't want to make a big deal about this. We're going to kind of blow through it. But consider the quadratic function whose equation is y equals x squared minus 4x plus 4. Determine the number of x-intercepts of this quadratic from the value of its discriminant. Then sketch its graph on the axis below. So b squared, same thing we've been doing, b squared minus 4 times a times c, right? So here we're going to have 16 minus 16. So in this case, this is when we're going to get that one rational root. So if you put this into your calculator, or if you found your roots, you'd find out your root is x equals positive 2. So what that means is that x equals positive 2 on your x-axis, you're going to get a parabola that has a tangent at positive 2. Okay, that was really not a very nice parabola. There we go. That might be a little bit better. Still not good. Remember, a sketch is a sketch. It's not really a graph. Maybe something like that. Well, let's see. That we know that the y-intercept is 4, so I'm a little bit lower than 5. So I think that's a pretty good representation. But here, this is what I'm talking about. All right? When it says here that the vertex of the parabola is going to be tangent to the x-axis, it means it's going to touch it right there. Remember last year when we talked about circles in geometry, and you had a circle with a tangent line? It means it hit it at just one spot. And that looks like it hits it at 2, but it really only hits it, supposed to only hit it at one spot right here. Not like a secant line that went through and hit it in 2 different spots. All right, so that's what we mean about one rational root. It's actually a double root, because to an x squared equation, you're always going to have 2 roots. To a cubic, you're going to have 3 roots, and so on. So let's quickly go through 4 and 5 so we can keep this video not so long. Too late, I know. Which of the following parabolas has 2 unequal rational x-intercepts? All right, now the one thing you could possibly do is graph them. But if you take a look at these, what we're looking for in order to have 2 unequal rational x-intercepts, we need a perfect square. Which one of these has a perfect square? That's the question here. All right, so if I look at these, b squared minus 4 times a times c. So here becomes 4 plus 60, which is 64. Now I just cheated because I knew that 2 was the answer. But you would check the rest of them. You would check this one over here and say b squared, which is 9, minus 4 times a times c. This is 9 minus 20, which is a negative 11. Of course, that's going to give you imaginary roots, and we know that's not the answer. And that's how you would go about finding which one of these is the correct answer. Or you could do the entire quadratic formula out on all of them, which would take a little bit longer, but you'd still get the right answer, hopefully. Last one, exercise 5. Again, this one isn't that hard either, but this is a little more abstract, and this is very Common Core. All right, this is really, if you really understand the concept of the nature of the roots and the discriminant. So exercise 5 says, for what values of a will the parabola y equals ax squared plus 4x plus 2. So here's my a right here. Okay, so will not cross the x-axis. So again, I want you to just think about what that means. It means it's going to look something like this. And we talked about this earlier in this unit where we said that if it doesn't cross the x-axis, that means it has to have imaginary roots. All right, so it's really important to take a moment and just make sense of the problem and translate it. So now, if it has imaginary roots, hopefully you're going to go back to, ooh, that means that the discriminant has to be negative. So we have b squared minus 4ac. Now beware that a is the same a that we have in our equation. So b squared is 16 minus 4 times a times c, which is 2. So it's 16, and we know this has to be negative. So it has to be less than 0. All right, so what do we have? We have 16 minus 8a has to be less than 0. I'm going to minus 16 from both sides. So I get negative 8a is less than negative 16, and I divide both sides by negative 8. And beware, because when you divide by that negative, every sign changes. This negative 8 becomes a positive 1a. The sign changes, and it becomes a positive 2. So a has to be greater than 2 in order for that to be a quadratic that has imaginary roots. Okay? So sorry, went over. I've been really trying hard to keep them under 15 or 20 minutes, and I'm at 23 now. But I thought there were really some important concepts I needed to make clear to you before I moved on. So that's the end of 9.4. We're going to get ready to review and test on Unit 9. Again, nice, short, quick unit. And then we're going to move on to Unit 10. So, and we're in the home stretch because we're in the last marking period of the school year. Gosh, it just seems like we started. But anyway, as always, make good choices every day when you wake up and get here on time. Be present for your life. Believe me, you're going to miss too much if you're not. All right, so see you next time.